So for number 37, we have this sequence right here, and we want to know if it converges. Well, a sequence an converges if an tends to a limit as n approaches infinity. So we're going to take the limit as n approaches infinity of 2n minus 1 factorial over 2n plus 1 factorial. And so because we're having a factorial on top and on the bottom, we want to expand these so maybe we can get them to match and we can cancel things out. And just a reminder of a factorial, if I have x factorial, this is the same thing as 1 times 2 times 3 times 4 times, so that's going to be x minus 2 times x minus 1 times x. So we can see here that if we have x factorial, we begin with x, and then we go removing 1, so times x minus 1, times x minus 2, times x minus 3, and so on, until we get all the way down to 1. So similarly, we're going to have the factorial of 2n plus 1. This is going to be equal to 1 times 2 times 3 times 4, and then we're going to work backwards, right? So we begin at 2n plus 1, 2n plus 1, and similarly, just as we did with the x, we're going to remove 1 from it. So this is going to be 2n plus 1 minus 1, so that's just 2n, and then 2n minus 1, right? We're going to go removing 1s, and then this would be 2n minus 2, and so on. And so we can see here that actually, if we isolate, not isolate, but if we compare it here, we can see that this part is just 2n minus 1 factorial, right? So it turns out that 2n plus 1 factorial is going to be equal to 2n minus 1 factorial, and then times 2n, and then times 2n plus 1. So I'm just going to zoom out so you guys can see that. So when we did the expansion, we said that, hey, from 1 all the way to 2n minus 1, that is 2n minus 1 factorial. And then if we multiply it by 2n, because we keep adding 1, and then multiply it by 2n plus 1, that is equal to 2n plus 1 factorial. So we're going to substitute this. We're going to say that this is limit as the n approaches infinity of 2n minus 1 factorial. And then on the bottom that we're going to have turn 2n plus 1 into 2n minus 1 factorial, and then times 2n, and then times 2n plus 1. So once we're here, we can see that these cancel out, right? And so let me just improve my handwriting a little bit. And so these cancel out, so that is the limit as n approaches infinity of 1 over 2n times 2n plus 1. Okay. So that's my new limit, because all I did was I went and I canceled out these two. And so when I have this, let's think about what is going to happen. I'm going to expand the thing on the bottom. So that is limit as n approaches infinity of 1 over, that is 4n squared plus 2n. Okay. So when n approaches infinity, it's going to be 1 over 4 times infinity squared plus 2 times infinity. So it's still going to be infinity, right? So it's going to be 1 divided by an infinitely large number. And whenever we take 1, or any number for that matter, and we divide by an infinitely large number, that division is going to tend to 0. So as we can see here, the limit of an, our sequence, as n tends to infinity, is going to be equal to 0, right? And so because there is a limit, it does approach a specific number, then we can say an approaches 0 as n approaches infinity, so an converges. So yeah. So what we did was we took 2n minus 1 factorial over 2n plus 1 factorial, and then we expanded 2n plus 1 factorial into 2n minus 1 factorial times 2n plus 1. Then we canceled things out, then evaluated this limit and found that it gave us 0.